Welcome to Web Handling. My name is Dave Roisum. We continue our tour of what may matter by talking about roller grooving. My first engineering job was for the once largest web machine builder in the world, the Beloit Corporation. This paper machine company had over 2,000 grooving styles in their portfolio. Some were holes, some were grooves, some were holes in grooves. Grooves could be narrow or wide. Grooves could be shallow or deep. Grooves could be oriented annularly, spiraled, chevron, or cross-direction. If they were spiral, it was usually outward, though we now know that matters not, except to match people's expectations, as we learned in a previous Web201 clip. We could have two different grooving patterns combined into the same roller, such as the wide shallow plus vena grooving for winder drums. We could have traction coating plus grooves. Let us begin by simplifying this situation. One of the most common reasons to groove rollers is to avoid a loss of traction on smooth webs run at or beyond moderate speeds. We covered this in great detail in Module 3 of our Web 101 course. Of course, as we learned there, other methods such as roughening rollers can also work equally well if there is sufficient volume to park the air. If we focus the discussion to air or fluid handling, we can use science to guide us to which grooving styles might work and then standardize or at least limit the variation in styles. Beloit Corporation eventually did just that. Their trademark, but often copied, vena groove pattern could handle the air on any size rollers to speeds up to 10,000 feet per minute with almost no detectable loss of traction. Later, we learned why this grooving could do this, as was first described in my roller book. There are three primary limitations that any air handling grooving must abide by. 1. The total grooving must have sufficient volume as determined by the combination of depth, width, and pitch. A simplified grooving sizer is given in the air lubrication calculator by Abbott app. 2. The grooving must not be too narrow, else manufacturing and maintenance costs increase, nor too wide, else the danger of web marking or wrinkling. Annular grooves are the worst here, but high-angle or helix grooves are much more expensive to machine. Note that some delicate products or coatings cannot run across any groove surfaces without marking, and that is a product design problem as much as anything else. 3. The pitch or spacing between the grooves must be short enough so that the air has time enough to go sideways to reach the groove. In summary, think of all of the tread patterns found on automobile tires. Almost all work pretty much the same for ordinary applications on ordinary roads. If you want to know more about the what, when, why, and how of roller grooving, there is no better place than my Web 101 course. Thank you so very much for watching this module in my Plant Practical video clips. Stay tuned as we continue our tour of what matters in web handling.